All right, so this is the image that we have been working on last session, and I'm just gonna continue this, whatever we have done. Today we're gonna continue the segmentation, and then I'm gonna add a few more branches probably, and then I'm gonna create a model out of this and create a mesh if we had enough of the time. Meanwhile, if you have any questions or any comments, any concerns about the segmentation, please let me know. So what I see here is that I do believe that Dr. Khan segmented this out, but I just see one segmentation right now here. All right, we will continue from here. It might be a little bit boring for you because you already have done the segmentation. Yes. Let's have all of the branches turned on. Right, I'm gonna add just a few circles. This is exactly where LV is coming out of the aorta. You see one of the examples of the vessels that we couldn't see maybe the time that we were segmenting this out. You see this septal branches coming out here. Let me just go a little bit off. At the same time, let's have locked in preview. So if you look at the vessel, you see here another branch is coming out of the LAD. Now sometimes this happens, you go through the segmentation, you see it's moving out. You go through the segmentations and you see new vessels that you couldn't see at the beginning. And sometimes it's really hard to go back and find them on the path, on the anatomical planes. All right, so this that you see here, maybe on this plane, this is a blooming artifact. This is a problem that happens in CTA image. It is an artifact that happens in CTA images because of the calcification. So basically, you cannot have a very good segmentation of the calcification itself. Another vessel, as you see, is coming out of the LED. This is another septal vessel, I do believe. Yeah, it's here. So I bootstrap. So one of the points is that you see that at the points that the vessels, another vessel is coming out of the main vessel that I'm segmenting. I usually don't put a circle here, and you will understand it why when we move on to the models. So basically, when you have a circle segmentation here, and then another vessel segmentation is going to come out of this, you will get an error when you're doing the modeling. So let's leave this here and we can see how that error could happen. And I try to have to add a circle every 3 or 4 I don't know what we call them, real slices, yeah, in every three or four slices. Obviously, we can see a narrowing in LAD. And you see sometimes the path that we have created is not exactly at the center of the vessel. So the vessel continues like near the path. Right, we have reached the end of the vessel. Let's add a few more vessels and then we can move on to the creating a model. I'm just gonna do the left side here. We will leave the right side for extra time maybe. So on the segmentation, create a controller. Let's do a guide. So as you see, this is LCX that is coming out, and this is the diet branch, and the one that I just segmented is LED. So as you see, the starting point for the diet branch is really up in the LED. So I just move on a few slices and then add the first segmentation of the diet. Okay, so now it's coming out of the vessel. You see another vessel is coming out of right here. On this slice, you can see it here. Another vessel is coming out of which we didn't create a path for that vessel initially. One of the problems that happens with synovascular is that it crashes many times. So every time that every few steps that you have done, it is better to save the project. So just in case if it crashed, you have everything that you did. It's just so it is actually a good idea if you go back through your segmentation, especially in the slices that we didn't do the segmentation, because it feels between the slices. And sometimes uh, this happens that the vessel segmentation doesn't match the exact vessel outline. But this was good actually. Right, let's do another diag. Again, I'm just gonna go a little bit forward because I don't see still the vessel. So now I can see the vessel is coming out. I go backward. So from here, just add a circle. So one of the issues that might happen is that you make this circle really big, that it touches the previous segmentation. So let's leave it as well like this. I want this to touch and to see the kind of the error that we will get in the modeling. If we look closely, it seems that another vessel is coming out of the second diode. So let's see it here. I just moved forward a few slices, and let's go back to see. Well, actually, it matches very well. I wanted to make a point here. Let's say, let's maybe see how it works with this. So let's go back to see how it works with this vessel. Okay, so maybe here, like the segmentation is a little bit narrower than the vessel outline, so I will add another segmentation. Okay, but in general, I think it was a good thing. So yeah, let's do the LCX branch, and then we move on to the modeling. In LCX 0, let's look at where the branch is coming out of your chart, or the left main actually. Okay, here the vessels comes out. Add a segmentation here. Let's go back. Okay, here is where I can add the first segmentation for this vessel. Let's actually have this like this. Let's see what happens. Oh, yeah, it was at the other end of the left main. Actually, it should be like this. Okay. So this is the type of problem that I have when usually I segment out LCX. Usually, um, basically, when you continue segmenting out LCX, at some level it is not visible anymore. Okay, now the resolution got really better. Especially in the gradient image, you can see that better. So I think there was a vessel coming out. Yeah, this is the OM, obtuse marginal vessel, which we didn't segment this out. I mean, we didn't create a path for this. But here you can see that another vessel is coming out. So let's go back through LCX and see if there's anywhere that the segmentation doesn't match the outline. Yeah, maybe here I will add another circle, much better. Let's see. Another circle here. Okay, good. So let's again save the project, and I'm going to move on to the modeling. So now we have 4 vessels that we segmented, and let's create a model. So I right click on models, I create a model. The type is polydata, we don't change the type, the model name, let's call it model 1 or patient 1. Maybe patient 1. Okay, and it created a model. I double click on that. You can see the list of the segmentations, with basically we don't have any segmentation here. So there's a create a model button. And here you can select on the segmentations. And I press OK. And let this run. Okay, so it gave me an error. It says there may be vessels that only partially intersect. And we know where that error is coming from. All right, so let's take a look. We have 2 caps. So what happens when you press the models? It creates walls and caps. Walls basically is the same as the lofting preview that you had. Let me just turn this off. And so we have the wall for LED. You see, this is the wall. I click on that, it is in yellow. We have this wall for diag 1, for diag 2. We have a wall for LCX right here. And let me just turn this off. Okay. Much better. And we also have caps. We have cap for LED. You see, this is the first cap for LED, because we don't have the aortic segmentation, so we have 2 caps for LED. Normally, if you had the aortic segmentations, it would have been inside the aorta, and there would have been no cap. And when there is 2 caps per vessel, normally there might be an issue somewhere. So this is the second cap. In case of LED, we know that we already needed 2 caps, but in case of LCX, you can see I have a cap LCX0 and another cap LCX02. And this is because I didn't, I intentionally placed the circle so that it doesn't intersect. It is not inside the left made correctly. So you can see there is another cap here. So this is the first cap, and the second cap is at the end of the vessel, like this. So what I need to do, so I realized that there is a problem. What I need to do is to go back and correct the first circle. I'll just move it back in. I save the project. I go back to the models. And again, I create the model. Okay, so this time we didn't get any warning from Synvascular. And for LCX, we only have one cap. It seems that that is good. One thing that you can do with the models is to show the edges. Just turn this on. So by default, Synvascular creates a mesh for each of the models that you have created. So this is a mesh, but it's not a very beautiful mesh. There's not some kind of a mesh that we would like. Okay, and on the caps, you see, this could be a problem for us. So what we can do is to remesh this. So I select all of the balls and the caps, and we have a remeshing point here. But before doing that, forgot one step. Let's hide the edges. And let's look at these areas that the vessels are coming out of this. It is not really, it is so, I don't know how to put it, so rigid. It's just like at some level we had, it is not blended into the other vessel. So maybe this is a better description. All right, so what I do is that I just select the walls. So none of the caps are selected. And so we were on the face-offs here. So I go to the local ops. And what I do is to decimate the locals and then do the smoothing, smooth the locals. You see how they've changed? One more time, smoothing. Okay, let's go back, decimate locals. And one more time, smooth locals. Okay, much better. And now we need to go back and let's take a look at the edges for the mesh. Let's see what happened to the meshes here. They blended in. And on doing this, let's look how the meshes changes. So this was how the mesh looked before, the edges looked before doing the smoothing. And let's redo this. And this is how it looks like now. So way better. But we need to do the remeshing. As you see, the decimation actually, at some level, it had distorted the mesh. So what I do is I select all of the faces, and on the face-offs, I just do this remeshing. You can actually ask it to estimate the size for us, and like seems that 0.25 is good. So I select remesh. And it takes a while. And so if you run the program on the terminal, you can see that it is doing some iterations for the remeshing purposes. to do the animation. Just give it a few moments and see what happens. So were you able to follow me? I assume that you're maybe good as well, but if you had any question, you can ask me at any point. So let's see, yeah, it was done. Okay, the very more beautiful edges we do have here. And let's take a look at the edges on the cap. So to move the vessel, you can press shift and move it so you can, move the vessel like this. If you want to rotate it, you do not need to press anything. It's just, you can rotate it. Right, yeah, way more better edges on the cap as well. So up until this moment, it seems that everything is going good. So I'm going to save the project. I'm going to hide the edges. And let's take a look, an overall look at how the model looks like. Now let's create a mesh. So I'm creating a mesh. Right click on the meshes, create a mesh. So it asks you to select a model. You can have more than one model for one patient, for one syndactyl project. So currently we have only one model. So I select this model and it is okay. I press OK. Now let's look at the patient one mesh. Right, so we have this global maximum edge size. And normally, if we had aorta, we would have chosen a larger edge size. So this is the maximum edge size that you can select for a model. If I had an aorta, I would select the 3 here. But now that all of the faces that I have are coronary arteries, I would put an edge length of 0.5. And here you have the local size. If you want one of the vessels to have a different edge length, you can basically select the local size here. You can put any other number that you want here. Like, let's put 45, 0.45 here. But for the rest of that, if I put it empty, then that's going to be just as the maximum edge size that we had here. I save it one more time. Let's run the measure. Let's see what happens. Okay. So I got an error. It says that it failed in generating the mesh. It doesn't say anymore. So let's go back to the terminal and see what happens. All right, so interesting error. It says that number of free edges on surface actually are too much. There are bad edges on surface. You don't understand this error, what exactly it says. So what I usually do here is that I go back and try to create a mesh vessel by vessel. Like I try to create a mesh for LED and then I add LCX, then I add diag 1, diag 2, then I can understand what is the problem, which one of these vessels is making the problem. So let's see, I'm removing this mesh. And I will go back to the models. Let's create a model with only LED. Okay. Okay, so now I have only the LED. I can do all of the steps of remeshing, and so right now there isn't any other vessel that is coming out of this, so we don't need to do the smoothing actually. But let's skip this, and I create a mesh. Patient 1. Let's put a global size of 0.5 and run the meshing. Okay, so when the matching was successful, you get such a message that it says that the mesh is done. It tells you what is the number of the nodes, the number of elements, and all of the informations that you would need for your mesh. I hit OK. Let's take a look at the mesh that we have. Let's turn this off. All right, so this is the mesh that was created for LED. Not bad. It's a good mesh. Let's look at the tabs. Okay, so now let's go back to the model and add another vessel. Because basically when you get an error while you're working on the meshing, while you're running the mesh, the problem is that you have no idea which one of these vessels is making that error. So this is why I need to go back. I start with one vessel and add the other vessels step by step so that I can understand which one of the vessels made the problem. Right now, I know which one of the vessels made the problem because I placed some of the segmentations intentionally. So let's just remove this mesh. But normally what happens is that you don't know what's going on. So one more time, let's create a mesh. Patient 1, the global size of 0.5, and one measure. Okay. So again, I know that LED and diag1, they're not making any problem for us. So let's add diag2. One more time, I need to remove this mesh and create another mesh. And every once in a while, I hit the save button. I don't want this to crash and I lose everything that I've done. Okay, let's run the measure. Okay. I anticipate that I probably will get an error here. Oh, interesting. So it seems that it didn't have any problem with the segmentation study I placed here, intentionally touching the surface. Okay, so let's move on to the model and add LCX. Okay. I will remove this mesh. I create another mesh. So 0.5 it is, one measure. Interesting. So in the beginning, it gave me an error. And right now that I ran this vessel by vessel, it runs perfectly. Interesting. How much Symbascular is capable of. Okay, so one of the problems that I knew that it makes a problem, especially when you have a lot of vessels. You see, when you have like, I don't know, 3, 4 vessels, at some level, I think Symbascular can create a mesh. But when you have more number of vessels, like 20 vessels, the meshing process is not that much robust. And this kind of segmentation would make a problem in that case. It made a problem in the beginning for us. It gave us an error and we couldn't understand what that error was. We couldn't understand which one of the vessels is actually making the problem. So I went through a pipeline to better be able to understand which one of the vessels is making the problem. And this time it ran, it worked. But the thing is that we know this kind of, actually based on my experience, I know that this kind of segmentations, that the segmentations is touching the surface of another vessel, it can make a problem. So now let's go back and you see the segmentation, it is touching the surface. And when you have higher number of vessels, like 20 vessels, sometimes symbascular crashes even because of something like this. Right, so I changed the segmentation. Let's go back to LV, where the diag is coming out. So this segmentation as well, let's see if it is touching the surface. Yes. So I just delete this and okay, it seems that without even this segmentation, we are having a very good preview of the vessel. So let's just save this and go back to the model. I create a model one more time. Okay, so everything looks to be good. Okay. I save this one more time and let's remove the mesh and create another mesh. I'll put 0.5. Okay, we've created a mesh. Let's turn this often preview off. Right, so now we were successful in creating the mesh. But the only thing is that every time that you go back through this process, you see, I didn't smooth locals here. So that is one of the problems, basically. So every time that you go back through this process, you need to redo everything. And that's a little bit tedious with Symbascular. So again, on the model, let's select the balls and go to the locals, I go to the decimation, decimate local, and the smooth locals. Okay, so 1 time decimation, 2 times smoothing. And I repeat the process 2 times. Smooth locals. Save the project. And let's go to the face out. Let's actually see what happens if I create a mesh right now without remeshing this. So remove this and create another mesh. Let's just put a global number here, 0.5 again. Let's see what happens. So this time meshing was successful. And I do believe that last time that, at first we get an error. And then when we created another model, because we didn't do the smoothing, we didn't get the same error. And we went back and we corrected segmentation. And basically, yeah. This time, even with smoothing locals, we didn't get any error. So let's take a look at the mesh. Let's take a look at the tabs. Yeah, it looks very good. Very clean and neat mesh. Okay, so I saved the project here. Were you able to follow me on creating a model and a mesh? Can I get some feedbacks from you? So was it good? Was it confusing? Or did I went on so fast on the pipeline?
It was good.
Okay. Okay, all right. All right,
Thank
thank
you.
you. Thank you, thank you. Thank you for your feedback. All right, so labs covers, okay. All right, I see. It seems that you're doing the same thing in the labs with Eurota, so that's probably uh, why it wasn't overwhelming, as you said. Okay. All right, so I would say you can continue doing the segmentation on different cases that you have. If you had any image, let me just stop the recording.